Hi folks, welcome back to the last video for 8.5 complex numbers in polar form. And so in this video, we're going to take a look at finding the powers of complex numbers as well as the roots of complex numbers, okay? So just like the previous video, we're going to hop into some examples and kind of see what we get. So example 12, find z to the fourth when z equals 2 cis 3 pi over 16, okay? And so let's write this out. Z to the fourth equals 2 cis 3 pi over 16 to the fourth. Okay, so all I've done is replace my z with the particular z that I'm looking at, the particular number I'm looking at. Okay, now, just like before, we're not going to just distribute this fourth power to the number, to the r and to the theta, okay? But we are going to do part of that. So we're going to take the r and we're going to apply the root to it. And then instead of 3 pi over 16 to the fourth, we're actually going to do 4 times 3 pi over 16. So we're multiplying here, okay? And so we simplify this. 2 to the fourth is 16 cis. I'm multiplying here, but I want to actually reduce first. 4 over 16 reduces to 1 over 4. And I end up with cis of 3 pi over 4. Okay. So let's write that out in general before we get to the next example. Okay. So z to the n. If I have z to some power, that means I have r cis theta to that power. And that's going to give me r to the n. So I do raise the r to the power, but I have cis of not theta to the n, but n times theta. Okay. If I'm looking to find powers of complex numbers in polar form, I'm going to use that formula. All right. Now, let's kind of look at example 13 real quick here. I have z to the fifth. So I know that in this case, my n would be 5. However, the problem is this is in rectangular form. It is not in polar form. And you know what I don't want to do? I don't want to sit and FOIL this out 5 times. So we are going to convert z to polar form first. Okay. This saves us from having to FOIL 5 times, right? That's very time consuming. So it's a good chance to remember how we do this, right? R equals the square root of 1 squared plus 1 squared. That gets me the square root of 2. And then my theta, I find the inverse tangent of b over a. And I know that this is either pi over 4 or 5 pi over 4. And I think about what quadrant this number is in. It's in quadrant 1. So I do not want to use the 5 pi over 4, but I want to use the pi over 4, just regular pi over 4, okay? So what does that mean? That means that instead of having z equals 1 plus I in rectangular form, I really have z equals root 2 cis pi over 4. And now that I have the polar form, now I can use the formula that we wrote before. Okay, so number 2, apply power formula. Okay, all right, so here we go. Z to the fifth is root 2 cis pi over 4 to the fifth. And now I'm going to raise the r to the 5th power, but I'm going to multiply the angle by 5. And so that's going to give me root 2 to the 5th cis of 5 pi over 4. And that, my friends, I think we were able to do this in less time than it might take you to FOIL everything out, all right, just by converting it from rectangular to polar form. All right, so let's get both questions on one page so we can kind of remember this formula, look over this again, see when we might use it, all right? But that's it for powers. Now, the last thing we're going to learn about is how to find roots of complex numbers in polar form, all right? So roots are sort of almost the opposite of powers, right? And so let's see what we get here. Example 14, find the cube roots of z equals 8 cis 2 pi over 3. Now I want to make a note here that when we say cube roots, that means we have 3 roots, okay? That means that we also need 3 answers. So cube roots means we have 3 answers. If I had a square root, I have 2 answers. A fifth root, I have 5 answers, okay? So find the cube root of z equals 8 cis 2 pi over 3 means we have 3 answers. All right, so a few things. We want to find the cube root of 3, right? So if we want a cube root, we actually have to put the little 3 out there. We can't just write with the square root symbol. But we know that this is really the same as z to the 1/3 power, all right? And so what we have here is we're going to find our 8 cis 2 pi over 3, and we're going to raise it to the 1/3 power, okay? And so it turns out that now it's going to be very similar to what we did before with our power. Okay, this, my friends, is going to give us 8 to the 1/3. So I apply the 1/3 power to the 8. But instead of raising 2 pi over 3 to the 1/3, I'm actually going to multiply it by 1/3. Okay, so we get 2 pi over 3 times 1/3. And then this might look familiar from when we were solving trig equations, plus 2 pi k over 3. Okay, so this 1/3 gets multiplied to our angle, but we have actually 3 answers. So the 2 pi k over 3 helps us find all 3 answers. All right, let's do a little bit of simplification. We get 2 cis of 2 pi over 9 plus 2 pi k over 3. Okay, but this, my friends, is not our final answer because I need 3 answers. So here's what we're going to do. We are going to sub in k equals 0, 1, and 2. Okay, so we're plugging in 0 for k, 1 for k, and 2 for k. That means our first root is z equals, let's call z sub 1 equals 2 cis of just 2 pi over 9 because k is 0, okay? The second root is going to be 2 cis 2 pi over 9 plus 2 pi over 3, all right? 2 pi over 3 because I am adding just 2 pi over 3 one time, k is 1. Okay, I'm going to combine my fractions, making sure I have the same denominator. I'm going to get 2 cis of 8 pi over 9. And I'll let you do that arithmetic, but you should get 8 pi over 9. All right, last root, because again, a cube root means I need 3 answers. I get 2 cis 2 pi over 9 plus 4 pi over 3. And when I combine those fractions, I should get 2 cis of 14 pi over 9. All right, so we said cube roots, which means we have 3 answers. We've got our 3 answers, so we're good to go. Okay, so if we were to think about this in general before we move to the next example, right? How might we write this? So z to the 1 over n, that's our root, is going to be r to the 1 over n, all right? Cis of theta over theta times 1 over n, okay? So theta over n plus 2 pi k over n, all right? Now, this is going to be for radians, right? If I give you a problem in radians, you want to use the 2 pi, because 2 pi is 1 time around the unit circle. But this is where it's really important to pay attention to details. We want to make sure we also know how to do this in degrees. And it turns out that it is pretty similar. R to the 1 over n, cis theta over n plus, oh, this is where it changes. We don't have 2 pi k over n. We have 360k over n. And that 360 means, hey, we know we're in degrees, okay? So 360 for when we're in degrees, but 2 pi when we're in radians, okay? All right, let's go ahead and take a look at example 15. All right, so example 15, the fourth root means we have 4 answers. Okay, fourth root, 4 answer. So let's apply our formula. Z to the 1/4 equals 16 cis 120 degrees to the 1/4. Okay, this is 120 degrees. So we really have 16 to the 1/4 cis of 120 over 4 plus, we better not write 2 pi here, right? Because we're in degrees. So we write 360 k over 4. All right. So small detail, but important. And the fourth root of 16 is 2. Cis 120 divided by 4 is 30 degrees. Plus, let's see, 360 cut up into 4 pieces is 90 degrees. Okay. So what we found is our formula, but we need to have 4 answers. All right, so that means we need to have our plug in k is 0, 1, 2, and 3. Okay, so Z1 will be 2 cis 30 degrees because we plug in k is 0. Z2 is 2 cis, Z30 plus 90 is 120. Z3 is going to be 2 cis, we're going to add 90 one more time is 210. And then Z sub 4 is going to be 2 cis, add 90 one more time, and we get 300. And so these 4 are our 4th roots of that complex number in polar form. Okay? All right. Let's get that all on one page for you so you can take a look at that. But that's it for 8.5. Thanks so much for stopping by.